students. In this video, we're going to go through section 8.3, which is about rational numbers. Our learning target today is I can compare and order rational numbers. So up here it says integers, fractions, and decimals make up the set of rational numbers. So integers, that was all of our whole numbers, 0, 1, 2, 3, 4, etc., and all of their opposites, -1, -2, -3, -4. And now we're also including fractions and decimals. That's positive and negative fractions and decimals. A rational number is a number that can be written as a over b when a and b are integers and b does not equal 0. This just means a rational number is anything that can be written as a ratio, as a fraction, like 3/4, that is a fraction. Or when we have a decimal, we can still write decimals as fractions. So anything that's written as a fraction, as a ratio, is a rational number. For example 1, we're going to graph each number and its opposite. So here we have 3/4. So let's label our number line, put 0 in the middle. Now I'm going to count by 1/4. So there's 1/4. Next I would have 2/4. 2/4 is the same as 1/2. And then next I would have 3/4. So there is my number, 3/4. Now its opposite needs to be the same distance away, but on the other side of 0. So instead of positive 3/4, the opposite is going to be negative 3/4. So count -1/4, -2/4, or -1/2, and -3/4. So there we go, 3/4 and -3/4, those are opposites. Again, with opposites, you can just change the sign, and here they are on our number line. Next, we have -1.6. So first, let's put 0 on our number line. And we need to get to -1.6. Now, this might be a little bit tricky. You might be thinking, how am I going to get to -1.6? What would I count by? Well, I take out the decimal and I think about this as the number 16. If I were to get to the number 16, what could I count by? Well, I could count by 4s, right? 4, 8, 12, 16. But because this is 1.6 instead of 16, I'm going to count by 0.4s. So I'll go to -0.4, -0.8, -1.2, -1.6. Again, it's just like counting backwards by 4s, 4, 8, 12, 16. We just have a decimal in each, 0.4, 0.8, 0.12, 0.16. So there we go, -1.6. Its opposite needs to be the same distance away on the other side of 0, meaning at positive 1.6. Again, opposites, we're just changing the sign. So this time we'll count up on the positives, 0.4, 0.8, 1.2, 1.6. All right, now let's work on comparing rational numbers. So first we're going to compare -1/2 and -3/4. To do this, we're going to go ahead and put them on a number line. So I only need negative numbers on my number line, so I'll put 0 all the way to the right because I only need the negative side. Now, -1/2 and -3/4 have different denominators, so it's kind of tough to compare them. But -1/2, if I were to multiply both of these by 2, the numerator and denominator, to get an equivalent fraction, I would get the equivalent fraction -2/4. So -1/2 and -2/4, those are the same thing. That's going to help us decide where to put that on our number line. So I'm going to count by 1/4, -1/4, -2/4, right? -1/2, same thing, and -3/4. And now I can plot my numbers. So first I have -1/2 or -2/4, and then I have -3/4. And now we're deciding which of these is greater. Well, remember on a number line, anything to the right, anything this way, is greater than anything this way. So that means -2/4 or -1/2 is greater than -3/4. Remember, the alligator eats the bigger one, so this means greater than. So -1/2 is greater than -3/4. We're again just recognizing that when it comes to negative numbers, don't just look at the number itself. Don't think about it as 1/2 and 3/4. These are negative numbers. Whatever is closer to 0, closer to being positive, is the greater number. Now we're going to compare -4 and 5/6 and -4 and 1/6. Luckily, these mixed numbers have the same denominator in their fraction, so that's kind of helpful. I'm going to actually start my number line at -4 and 1/6, and then I'll just count by 1/6 for each. So this would be Negative 4 and 2/6. 2/6 is the same as 1/3. This would be negative 4 and 3/6, which is the same thing as negative 4.5. This would be negative 4 and 4/6, which is the same as 2/3. And we actually need to extend this just a little bit longer. Right there, we'll put negative 4 and 5/6. All right, so we were counting by negative 1/6. We're going to plot our two different numbers, negative 4 and 5/6 here, negative 4 and 1/6 there. And again, remember on a number line, anything to the right is greater than anything to the left. So that means that negative 4 and 5/6, which is right here, is actually less than negative 4 and 1/6. Again, this means less than because it's eating this one over here. So negative 4 and 5/6 is less than negative 4 and 1/6. Again, we can't just think about these as the positive numbers 4 and 5/6 and 4 and 1/6. We have to think about them as negatives. Negative 4 and 1/6 is closer to 0. It's closer to being positive. It's further to the right, so it is the greater number. All right, now we're going to compare decimals. So here, we're going to compare negative 2.3 and negative 1.5. I am going to go ahead and put negative 1.5 right there, and I'm just going to count by tenths, by 0.1s. So next would be negative 1.6, negative 1.7, negative 1.8, negative 1.9, negative 2, or 2.0, negative 2.1, negative 2.2, negative 2.3. Now I can go ahead and plot my numbers, negative 2.3 and negative 1.5. Again, anything to the right is greater than anything to the left. So if we look at this, we can see that negative 2 and negative 2.3, negative 2 and 3/10, is actually less than negative 1.5. Negative 2.3 is less than negative 1.5. Remember, the alligator eats the bigger one, so if it's eating this over here, that means this number is less than the other one. Again, remember with negative numbers, don't just look at the 2.3 and the 1.5. Don't cover up those negative symbols. We have to think about them as negatives because negative 1.5 is going to be closer to 0, closer to being positive, further to the right. That's the greater number. And finally, let's compare negative 3.08 and negative 3.8. So what I'm actually going to do is I'm going to start my number line at negative 3 over on the right, and I'm going to count by tenths again. So this would be negative 3.1, negative 3.2, negative 3.3, negative 3.4, negative 3.5, negative 3.6, negative 3.7, negative 3.8. And you might say, Miss Reed, I don't see the negative 3.08 on here. Well, we're going to just estimate about where that's going to be because for this activity, we don't need to necessarily have an exact right placement. We just need to decide which is greater, which is further to the right. So an estimation is going to be just fine. So let's think about negative 3.08. So 0.08, 8 is in the hundredth spot, so this means 8 hundredths. 8 hundredths. We need 10 hundredths to make 1/10, right? This is going to be 3 and 10 hundredths, 3 and 1/10. So I'm just before that. I'm almost to 1/10, right? I have 8 100ths. I need 10 to be at 1/10 to be at 0.1. I'm almost there. So I'm going to be just before that. That's about where negative 3.08 is going to be. It's going to be further left than negative 3, but it's going to be just before negative 3.1 because, again, it's only 8 100ths, not 10, and we need 10 100ths to make that 10th, 0.1. Then we're going to plot negative 3.8 over here. Now we need to decide which is greater. Remember, for things further to the right are greater than things to the left. That means negative 3.08 is actually greater than negative 3.8 because, again, things to the right are greater than things to the left. Now, let's say you didn't have a number line to do this problem. Let's talk about how you could do it anyways. If I were to cover up my negative symbols and imagine that these were positive and I were comparing 3.08 and 3.8. To compare decimals, I look at the place value, and then if they're the same, I move to the next place value. And I keep going until I have a place value where they differ, and that's how I decide which is greater. So if I look at the ones place, the 3, they're the same. So I would need to move to the tenths place. This is a 0 and this is an 8. That would mean that this one, 3.08, is closer to 0. So if they were positive, that would actually be less. But remember, these are negative, so it means it is actually more. It's almost like doing the opposite thing as comparing positive numbers, right? If you need to, you can even think about them as positive numbers and then just recognize that you're going to have to swap that. That if this is a greater positive number, or if this is a lesser, smaller positive number, it's actually a greater negative number. So again, with negative numbers, imagine what is closer to 0, closer to being positive, what is further to the right on the number line. That is our greater number.